Okay, Eddie plans to have a deposit of €400 at the end of each month for 3 years in a savings account earning 3.25% AER. What single sum of money would Eddie need to invest now to achieve the same future value? Okay, so what we're looking at here is we have to find out what sum of money will this be worth, okay, at the end to figure out how much he needs to invest now. So he plans to deposit €400 at the end of each month for 3 years, 3 years being 36 months, an account earning 3.25% APR. So our 1 plus I, our monthly interest has to be the same as 1.0325. Our B value is therefore going to be 1 plus I, and that's going to be the 12th root of 1.0325. So once again, the 12th root of 1.0325 is going to be equal to 1.0026. So we're going to shift, we're going to store, and we're going to save that as B. Okay, so it's at the end of each month for 3 years. Okay, so our final value now at the end of December 31st, we're going to make a payment. This payment of €400 is going to remain at the value of €400. Okay, and then the next payment on will only have 1 month of interest to accumulate money. The next one will have 2 months to accumulate money, and the very first investment will only have 35 months to accumulate money. So once again, it's an SN sequence where it's A into 1 minus Rn all over 1 minus R. A is 400, N is going to be 36 different installments, and R equals B. So then we can put this into the calculator and find our F value to be 400 multiplied by 1 minus B to the 36 all over 1 minus B. Put that into the calculator, we get 400 bracket 1 minus B to the power 36 all divided by 1 minus B. And what we get here is 15,093.34. So this is the future value, okay? Now Eddie is thinking about just investing a single sum of money. So Eddie's single sum of money will let equal to P. So it's going to be 1 plus I to the power of T. So the future value is 15,093.34. Our P value we don't know. Now we're going to do it by yearly amounts this time. So he's going to invest it for 3 years. So it's going to be 1.0325 to the power of 3. So if I divide this number here, and we're going to divide that by 1.0325 to the power of 3, what we can find out is what lump sum of money can you invest today, which is going to be 13,712.45. So 13,712.45 is something that you can invest all in one lump sum, and in 3 years time it will be worth the same amount as investing 400 at the end of every month. Okay, so now we're on to number 12. You've won a prize in a lottery. The prize entitles you to €1,500 per month, paid at the end of each month for the next 20 years. How would you prefer to have it? The entire amount now in a lump sum. If the AER is 5.5%, how much would you accept as a lump sum? Okay, so what we're going to get here is, once again, we're going to do a sequence paid at the end of each month, and it's going to be for the next 20 years. 20 multiplied by 12 gets you 240. Okay, So our final, and then we're going to use f equals p into 1 plus I times t. Now, we want to change this yearly amount into a monthly amount. So 1 plus I to the power 12 equals 1.055. Our b value is going to be 1 plus I, and that's going to be equal to the 12th root of 1.055. Now the 12th root of 1.055 is b. That's going to be our b value. Now this is a geometric sequence where Sn equals, so it's our last value. Our last value is going to be €1,500 per month paid at the end of each month. So this €1,500 has no time to accumulate value. The 1,500 B1, our second last payment, accumulates value. Our third last payment accumulates 2 months of value, while our very first payment would accumulate 239 months of value. Once again, it's a geometric series where an equals 1, a into 1 minus rn all over 1 minus r. Our a value is 1,500, our beginning value. Our r value is b because it goes up by b every time. And our n value is going to be 240. So, what we get here is Sn equals 1,500 divided by 1 minus b to the power 240 all over 1 minus b. So you put this into your calculator, and we get is 1,500 into 1 minus b to the power of 240. Okay, and then all over 1 minus b. And what we get here is 643,298.28. So it's 643,298.28. Now guys, this is the future value, okay? Or sorry, this is the future value we can get from all these investments, okay? But if we want to accept it as one lump sum today, like a p-value, we got to do it in terms of yearlies, okay? Now the yearly value is going to be 20. Our yearly interest rate is 1.055. Our future value is in 20 years time is this amount here. And then we have to find out our p amount. What amount will I accept today that will accumulate into this value here? So what I get is this answer divided by 1.055 to the power 20, and what I get here is 220,479.95. So our present lump sum that we'd accept is 479.95.